Okay, now let's talk about the biomolecules. So bio का मतलब क्या होता है? What do we understand by bio? Living, है ना? Something related to living organisms. So biomolecules are the present in molecules present in living organisms, right? So biomolecules are the molecules which are present in the living organisms. Now we can also define the biomolecules as the complex organic molecules which form the basis of life, that is, which build up the living organisms and are required for their growth and maintenance. ठीक है? So basically ये जो biomolecules है, they make up the living organisms like your proteins. Proteins are the building blocks of the body. ठीक है? So they build up the living organisms and are required for their growth and maintenance, like your carbohydrates, vitamins. ठीक है? ये growth and maintenance के लिए चाहिए. So ये सब क्या है? Biomolecules. They may be simple or they may polymerize to form large molecules, which we also call as macromolecules. They may be simple like glucose, amino acids. Now these are simple molecules, very small in size, so generally called as micromolecules. And when they polymerize, they form large molecules called as macromolecules like proteins. So they may be very simple like the micromolecules, or they may polymerize to form the macromolecules like proteins, right? So some of the examples are carbohydrates, amino acids, proteins, enzymes, nucleic acids, lipids, hormones, and vitamins, etc. Note down the definition. Now we'll be studying these one by one, the important ones. The first one is carbohydrates. Now carbohydrates are also referred to as saccharides. Saccharum means sugar, which is sweet in taste. Okay? So their carbohydrates are also called as saccharides or sugars. Now what are carbohydrates? Polyhydroxycarbonyl compounds. Okay? Polyhydroxy means where more than one hydroxy group is present, and carbonyl compound refers to aldehyde and ketones. Right? So aldehyde and ketone के साथ hydroxy group is also there. So these are generally optically active. They show optical isomerism due to the presence of chiral carbons present in the compound. So optically active polyhydroxyaldehydes or polyhydroxyketones, or compounds which give these on hydrolysis. Okay? So what are carbohydrates? You can remember it as polyhydroxycarbonyl compounds. And carbonyl compounds include aldehydes as well as ketones. Right? Now let's see the classification of carbohydrates. Now this classification is based on the number of units obtained on hydrolysis if they undergo hydrolysis. Not all of them undergo hydrolysis. If they undergo hydrolysis, then the number of units produced after hydrolysis, that will tell us the type of carbohydrate. Now the first one is monosaccharide. Mono matlab single, single unit. So monosaccharide means a single unit. These are also called as simple sugars. Why? Because यहाँ पर ये सबसे smallest unit रहता है. ठीक है? This is like the smallest unit which cannot be simplified further. So these do not undergo hydrolysis further. So they are the smallest ones, smallest units, and they cannot be broken down further. So the examples are glucose, fructose, mannose, etc. Right? Mono matlab single unit, and it cannot be broken down further because they are the simplest units, they are the smallest units. Then the second type is oligosaccharides. Now these are made up of 2 to 10 units of monosaccharide. ठीक है? And because they are made up of 2 to 10 monosaccharide units, so when hydrolyzed, they will break down, giving 2 to 10 units of monosaccharide units. Right? जितने यूनिट से बना होता है हाइड्रोलिसिस पे उतना ही यूनिट्स में ब्रेक हो जाता है. So generally these oligosaccharides are made up of 2 to 10 units. So on hydrolysis they will break down, giving 2 to 10 units of monosaccharide. Now suppose if the oligosaccharide is made up of 2 units, it is generally referred to as disaccharide. Di meaning 2. Disaccharide, it is made up of 2 units, like for example sucrose, maltose, lactose. Now see, we have sucrose which is made up of 1 unit of glucose and 1 unit of fructose. So they make up sucrose, and on hydrolysis it will break down, giving 1 mole of glucose and 1 mole of fructose. तो जितना यूनिट से बना है उतना ही यूनिट्स में ब्रेक हो जाता है. ठीक है? Likewise, maltose, it is made up of 2 units of glucose. So when hydrolyzed, it will break up, giving the same 2 units of glucose. Same way for the lactose. ठीक है? 2 units से बना है, so it will break up, giving 2 units, one of galactose and the other of glucose. Then the third type is polysaccharides. Just note it down. Okay, now this before doing polysaccharides, let's see a few more examples of oligosaccharide. Oligosaccharides with 3 units are called as trisaccharide. ठीक है? अगर 4 units से बना है तो tetra, 5 units से बना है तो penta, and 6 hexa, and so on. So 3 units से, if it is made up of 3 units, and on hydrolysis it will produce 3 units. So such oligosaccharides are termed as trisaccharides. Example is raffinose with molecular formula C18H32O11. Then poly means which is made up of many monosaccharide units. ठीक है? Oligo में range क्या था? 2 to 10 monosaccharide units से वो बनता है और उसी में ही ये break होता है on hydrolysis. Greater than 10 units of monosaccharide if we have, then it is called as polysaccharide. So they are usually made up of greater than 10 monosaccharide units, and on hydrolysis they will produce the same number of units जितने units से वो बना है. ठीक है? Whatever the number of units it is made up of. The general formula क्या होता है इनके लिए? C6H10O5 whole n times. Now this number n is an integer which varies from 100 to 3000. ठीक है? So generally ये जो polysaccharides होते हैं, they are made up of large number of monosaccharide units. The common examples are starch, cellulose, inulin, glycogen. ठीक है? And ये जो polysaccharides होते हैं, they may be made up of a single unit or maybe a combination of 2 or more units. Right? If they are made up of a single unit, like cellulose is made up of only glucose. So if they are made up of a single monosaccharide unit, they are called as homopolysaccharide. Homopolysaccharide. ठीक है? If they are made up of a single, homo means same. So if the monosaccharide unit is same throughout the chain, throughout the polymer, so it is called as homo. And if it is made up of 2 or more monosaccharide units, then it may be termed as heteropolysaccharide. Heteropolysaccharide. ठीक है? So this classification was based on the number of units which it produces on hydrolysis. Now the next classification is based on water solubility. So carbohydrates are further classified into sugars and non-sugars. Sugars generally कैसे होते हैं? Crystalline in nature and they are water soluble. right? Sugars are generally crystalline, water soluble, sweet in taste. है शुगर्स का टेस्ट कैसा होता है? स्वीट. तो जो the ones which have sweet taste generally your monosaccharides, glucose, fructose and disaccharides. ठीक है, like sucrose. So monosaccharides and disaccharides, they fall in this category. They have sweet taste, they are water soluble, have crystalline nature, and the ones, the polysaccharides, fall in this category. Starch and cellulose are polysaccharide. They are non-crystalline. We can call them as amorphous. They are insoluble in water, and generally they do not have any taste. They are tasteless. तो इस कैटेगरी में क्या आ जाएंगे आपके? पॉलीसैकेराइड्स. ठीक है, तो पॉलीसैकेराइड्स are generally referred to as non-sugars, and your monosaccharides and disaccharides, they fall under this category. They are generally termed as the sugars because they are sweet in taste and water soluble. Go through the classification. There are so many other compounds which are far more sweeter than the carbohydrates. Like there is this aspartame, a peptide, which is 160 times sweeter than sucrose. And then you have saccharin, which is 500 times as sweet as sucrose. Then there is monal-lalin, which is a protein and about 2000 times sweeter than sucrose. So there are many other compounds which are far more sweeter than the carbohydrates. Now let's see the third classification of carbohydrates. This is based on the reducing property, right? So carbohydrates are further classified as reducing sugars and non-reducing sugars. Those sugars which can be reduced, which can reduce Tollens and Fehling solution. ठीक है, इसमें बेनेडिक्ट भी डाल सकते हैं. Which can reduce these Tollens and Fehling reagent and Benedict solution. They are termed as reducing sugar. ठीक है, so ये Tollens वगैरह क्या है? These are mild oxidizing agents. Now because these are mild oxidizing agents, they will oxidize the aldehyde or the alpha hydroxy ketone. They will oxidize these compounds and themselves they will get reduced. So these are mild oxidizing agents. ये खुद क्या होते हैं? Reduce होते हैं और साथ वाले compound को oxidize करते हैं. ठीक है? So in terms of, अगर हम in terms of carbohydrate बात करें, so carbohydrate इनको reduce कर रहे हैं और खुद oxidize हो रहे हैं. So those sugars which can reduce the Tollens and Fehling reagent or Benedict solution, they are termed as reducing sugars. And those which cannot reduce these particular solutions, Tollens, Fehlings or Benedicts. Generally हम Tollens and Fehlings लेते हैं, but Benedict भी ले सकते हैं. So those sugars which cannot reduce these reagents, they are termed as non-reducing. अब इसमें जो examples है, generally all your monosaccharides, जितने भी monosaccharides हमने पढ़े हैं, ठीक है, and disaccharides except sucrose. Disaccharides में except sucrose. So all monosaccharides like glucose, fructose, they act as reducing sugars, and all disaccharides except sucrose. Disaccharides में lactose, maltose ये सब, except sucrose, they act as reducing sugars. Meaning they reduce the Tollens and Fehling reagent. ठीक है, तो जब हम इनके स्ट्रक्चर्स पढ़ते हैं तो क्या होता है, जो भी इनके साइक्लिक स्ट्रक्चर्स है, they can change into the open chain form, releasing the free aldehydic group. ठीक है, so जहाँ पर भी free aldehydic group होगा वहाँ पर ये reduce कर पाएंगे, और जहाँ पर free aldehydic group में वो convert नहीं हो पा रहे हैं, जैसे कि यहाँ पर, so जो इनके cyclic structures होते हैं इन compounds के, so they cannot they cannot convert into the open chain form, yielding a free aldehydic group. So when these free aldehydic groups are not present, generally the reactions are not seen. So once you do the structures, it will become more clear. ठीक है, तो जहाँ पर free aldehydic group present होता है, generally वो reduce करते हैं और जहां पर प्रेजेंट नहीं होता है जनरली दे आर नॉन रिड्यूसिंग. So just remember, reducing sugars reduce these reagents, toluenes, phenins and benedicts, and non-reducing do not reduce these reagents. तो यहाँ पर क्या आ जाएंगे, जो भी आपके सारे पॉलीसेकेराइड्स है, all polysaccharides like the starch, cellulose and sucrose. Sucrose is a disaccharide. So all disaccharides fall in this category except sucrose, which is a non-reducing sugar, and starch, cellulose. All polysaccharides fall under this category. They are non-reducing in nature. Further, let's see the classification of monosaccharides. अब monosaccharides जो हैं, जो हमने स्टार्टिंग में पढ़ा कि वो फर्दर हाइड्रोलाइज नहीं हो सकते, they are the simplest sugars. Now they are further divided into aldoses and ketoses depending upon the type of functional group present. If the type of functional group is an aldehyde, we call them as aldoses. If the functional group is a ketone, then we call them as ketoses. ठीक है, तो जैसे नाम से पता चल रहा है ald. Ald stands for the aldehyde functional group and keto stands for the ketone. The general formula is this. There's this aldehyde group CHO, CHOH, N times. N may vary from 1 to 7 and another CH2OH group. ठीक है, तो एक ये प्राइमरी एल्कोहलिक ग्रुप होता है, सेकेंडरी एल्कोहलिक ग्रुप्स and an aldehyde group is present. Now if the value of N is 1, if we put N as 1, N की जगह 1 लगा देंगे तो एक ही यूनिट है CHOH, तो सिंपलेस्ट क्या बना हमारे पास एल्डोस, 3 कार्बन का सिंपलेस्ट एल्डोस बनेगा. That is called as, because we have 3 carbons, so we call it as triose. ठीक है, so aldo because the aldehyde group is there, and tri because there are 3 carbons, so triose. This is also called as glyceraldehyde. The common name is, this compound is glyceraldehyde. So this is the simplest aldose of 3 carbon atoms. Likewise, if you put NS2, अगर हम N को 2 पुट कर लेंगे तो ये क्या हो जाएगा, CHOH whole twice. Then it will be termed as, now how many carbons are there, 2, 3, 4. So it will be termed as 4 carbons, so tetrose, aldo tetrose, right? So just keep on increasing the number of carbon atoms. So if N is 3, then the total number will be 3 carbons here and 2 more, 5. So aldo pentose, right? So likewise, we'll increase the number of carbon atoms. Now if N is 4, so CHOH 4 times हो जाएगा और total carbons कितने हो गए, 4 and 2, 6. So we call it as aldohexose. Now aldohexose का जो important example है, that is glucose. Glucose belongs to this category. It is an aldohexose. Okay, so if you keep on increasing the number of carbon atoms, so that is how the different aldoses are formed. Now let's see the ketoses. The second type of monosaccharides are ketoses. ठीक है, तो जैसे नाम से पता चल रहा है, keto means there is a ketone functional group. अब ketone के लिए क्या क्राइटेरिया होता है कि C डबल बॉन्ड होके दोनों तरफ कार्बन होना चाहिए, so it cannot be at the terminal position. ठीक है, तो ये हमें, जैसे एल्डिहाइड यहाँ पर था फर्स्ट कार्बन पे, लेकिन कीटोन कहाँ होगा, सेकेंड कार्बन, बिकॉज कीटो ग्रुप हैज टू बी बिटवीन 2 carbons. Now this is the general formula for ketosis. The general formula is CH2OH. ठीक है, प्राइमरी आपके एल्कोहलिक ग्रुप्स होते हैं, और फिर C डबल बॉन्ड O, CHOH N times. Here N may vary from 0 to 6. ठीक है, तो थोड़ा सा फर्क है. In the previous case we had an aldehyde group right at the terminal position. Here we have a hydroxy group first, then the ketonic. Okay, now let's put N as 0. What do we get? If N is 0, this is not present, then the simplest कीटोस विल बी CH2OH C डबल बॉन्ड O, ये प्रेजेंट नहीं है, तो नेक्स्ट CH2OH. This will be the simplest ketose with N equals to 0. Now how many carbons? 3. So it will be termed as ketotriose. ठीक है, जैसे प्रीवियस केस में एल्डो वर्ड हमने यूज किया था, एल्डोट्रायोस, हियर वी विल कॉल इट एज ketotriose. Now put NS1, so CH2OH C double bond O CHOH. This is only one time, so just write it once, then CH2OH. Right? Now how many carbons present? Total 4 carbons are there. So keto, because the ketone functional group is there, so keto, और ट्राई के बाद क्या आता है? टेट्रोस. So keto टेट्रोस. ठीक है, सो वट एवर द फंक्शनल ग्रुप इज, वो स्टार्टिंग में लगाएंगे एल्डो या कीटो, एंड ऑन द बेसिस ऑफ द नंबर ऑफ कार्बन्स वी पुट अ ट्रायोस, टेट्रोस, लाइकवाइज. सो सिंपलेस्ट ट्रायोसिस होते हैं. अब यहाँ पर अगर n का वैल्यू 2 कर दें तो CHOH होल ट्वाइस हो जाएगा. टोटल नंबर ऑफ कार्बन्स कितने हो गए? 2, 3, 4, 5. ठीक है, ऑलरेडी वी हैड 4, 1 we have increased, so it becomes pentose. So keto pentose. ठीक है, keto for the functional group, pent for the total number of carbons. So there are 2 carbons here, 3, 4, 5. So 5 carbons के लिए pentose. Likewise, if I have the value of NS3, n को अगर 3 ले लें और यहाँ पर भी CHOH whole thrice कर लें, so carbons 3 हो गए, 3 more are there, so that makes 6. Then we will call it as a ketohexose. अब जो fructose है, that belongs to this family, ketohexoses. ठीक है, fructose belongs to this family of ketohexoses. So the classification is clear. The monosaccharides, depending upon the type of functional group, they are divided into aldoses and ketoses. Then the general formula is for aldehyde, यहाँ पर क्या होता है? CHO. ठीक है, तो अगर aldehyde है तो CHO, CHOH, N times CH2OH. This is the general formula for the aldoses. ठीक है, तो सिंपलेस्ट में कितना होगा? कम से कम 3 कार्बन एटम सिंपलेस्ट एल्डोज में होगा, और जो सिंपलेस्ट आपका कीटोस है उसमें भी 3 कार्बन्स होगा. व्हाई? बिकॉज यहाँ पर n may be 0 आल्सो. ठीक है, सो बोथ द एल्डोजेस एंड कीटोस हैव द सिंपलेस्ट. जो एल्डोजेस एंड कीटोस है उसमें मिनिमम 3 कार्बन्स शुड बी देयर. सो इफ द एल्डिहाइड ग्रुप इज देयर, एल्डोजेस. इफ द कीटोनिक ग्रुप इज देयर, कीटोजेस. यहाँ पर n का वैल्यू याद रखना है, 1 to 7 रहता है, और यहाँ पर 0 to 6. Just go through.